Hello everyone. In this video, we can see about study of Ragel scanner software in compiler design. It is presented by Ravinayam. First, Ragel state machine specifications. A Ragel input file consists of a program in the host language that contains embedded machine specifications. Ragel normally passes input straight to output. When it sees a machine specification, it stops to read the Ragel statements and possibly generate code in place of these specifications. Afterwards, it continues to pass input through. In figure 2.1, a multi-line specification is used to define the machine and single-line specifications are used to trigger the writing of the machine data and execution code. In figure number 2.1, passing a command line argument. A small program is given. Next. Ragel state machine specifications. First, we can see about naming Ragel blocks. Its syntax machine FSM underscore name semicolon, which means the machine statement gives the name of FSM if present in a specification. This statement must appear first if a machine specification does not have a name. Then Ragel uses the previous specification's name. If no previous specification names exist, then this is an error. Second, machine definition. Name equal to expression semicolon. The machine defines statements associates an FSM expression with a name. Machine expressions assigned to names can later be referenced in other expressions. A definition statement on its own does not cause any states to be generated. Number 3. Including Ragel code. Syntax. Include FSM name input file.rl semicolon. The include statement can be used to draw in the statement of another FSM specifications. Both the name and input file are optional. However, at least one must be given. Without an FSM name, the given input file is searched for an FSM of the name as the current specifications. Without an input file, the current file is searched for a machine of the given name. Fourth, importing definitions. Import input file.h. The importing statement grabs a file for sequence of tokens that match the following forms. Ragel treats these forms as a state machine definition. Name equal to number. Name equal to lit dar underscore string. Define name number. Define name lit underscore string. Next, lexical analysis of a Ragel block. Within a machine specifications, the following lexical rules apply to the input. The symbol begins a command that terminates at the next new line. The symbols behave as the delimiters of literal strings. Within them, the following escape sequence are interrupted. Franchless 0, Franchless A, Franchless B, Franchless C, and so on, and Franchless R. The pattern 0 cross denotes an integer in a hexadecimal format. Any amount of white space may separate tokens. The symbols set bracket delimit a block of host language code that will be embedded into the machine as an action. Within the block of host language code, basic lexical analysis of commands and strings is done in order to correctly find the closing brace of the block. Regular language operators. When using regular, it is Ragel. It's helpful to have sense of how it constructs machines. The determination process can produce results that seem unusual to someone not familiar with the NFA to DFA conversion algorithm. In this section, we describe Ragel state machines operators. Though the operators are defined using epsilon transition, it should be noted that this is for discussion only. The epsilon transition described in these sections do not persist. but are immediately removed by the determination process, which is executed at every operation. Ragel does not make use of any non-deterministic intermediate state machines. Some of the operations like union, intersection, concatenation, difference, strong difference, cleanse, store, negation, repetition. State machine minimization. This algorithm implemented is similar to half-cross state machine minimization algorithm. Half-cross algorithm assumes a finite alphabet that can be listed in the memory, whereas Ragel supports arbitrary integer alphabets that cannot be listed in memory. Though exact analysis is very difficult, Ragel minimization runs close to theta of n into log of n order of and requires order of n temporary storage where n is the number of states. Thank you.